Hey y'all, in this lesson we're going to be looking at truth tables for compound statements and equivalent statements, where we're going to be exploring equivalent statements. For conjunctions, that's the word and. For the conjunction of P and Q to be true, then both P and Q have to be true. So it's a little more restricted than or, which we'll look at next. I have a couple examples here. Monday follows Sunday. That's true. And May follows April. That's true. So since both are true, the conjunction is true. Now, if I say Monday follows Sunday, that's true. And May follows July, that's false. This and here means that both have to be true. And one of them is not true. So we're going to say that this is a false statement. For disjunction is the word or, and basically if one of them is true, then the disjunction is true. The compound statement is true. So for the only time that, the disjunction will be false is if both are false. So if we had true or true, that's true. True or false, that's true. False or true, that's true. False or false, that's the only time it's false for or. It's a little less restrictive. So if we say I have a quarter or I have a nickel, if one of those is true, then it's true. And then if I say a quarter is worth 50 cents or a nickel is worth 10 cents, those are both false. So statement is false. Compound statement is false. So we're going to use that to help us do truth tables down here. And just to kind of give you some background with truth tables, when you have two statements, P, Q, then you always set it up with the P statement first, two trues, two falses. Q statement next, true, false, so alternate them. And that's just going into like basically different combinations of how these could be joined. And then, so you can see in the next table, it still follows two trues, two falses, alternate true, false. So it's always going to be set up like that. Then in the third column, we're using and as our connective. So based on the previous two truth values, if I were to say true and true, that's true. True and false, that's false. False and true, that's false. False and false, that's false. Because remember, for something to be true, they had to both be true. So for and, we only have one true in our final column. Now for or, remember, it's a little less restrictive. True or true, true or false, false or true. So those are all true. Now in the last case, that's the only one that's false. False or false, that's false. So they're kind of flip-flop, the and or, the last columns of the and or. So we can use that to help us build different truth tables. So if we have statements, in this case, the statements don't even really matter. I don't even really need to know what P or Q are. So it doesn't matter. But what I do know is that I do have two statements, PQ, so that's 4 rows for the truth values. And then I also have a not P in there. So instead of just having PQ columns, I added this not P in there to kind of help me. It's kind of like order of operations. We're kind of like dealing with the small pieces first before we can join it together at the end. So for P, I'm always going to have two trues, two falses. And then for Q, I'm always going to have alternating. That never changes. Now for not P, that's kind of a new element here. Not P means I'm negating the truth values in the previous column. So true becomes false, false, true, true. So I've made them opposite. And then for my last column, I'm focusing on these two columns. because what I'm really looking for is not P and Q. So these are joined by and. Not P and Q. So false and true is false. False and false is false. True and true is true. True and false is false. So technically, this column is my final answer. That's what I'm really looking for. Okay, number 2, we add in another statement. So R appears in this example. So that's going to extend my rows. In the previous example, I had 2 statements and 4 rows. Now I have 3 statements and 1, 2, 3, 4, 5, 6, 7, 8 rows. And where that comes from is you do 2 raised to the number of statements. So 2 to the third is 8. So that's going to change our statements a little bit. But anytime you have 3 statements, it's going to follow this pattern. So we've got 4 trues, 4 falses, 2 true, 2 false, 2 true, 2 false, and then true, false, true, false, true, false, true, false, all the way down. So every time you do a truth table with 3 statements, it's going to follow that pattern. It's going to have 8 rows, and it's going to follow those patterns. Okay, sorry. I'm trying to stress that because I always have a lot of questions on that. And then I want to focus on each element of my compound statement here. So let's pretend like you weren't given the table and you don't know which rows you need or columns you need to set up. So basically, I want to give you the tools that you need so that you can draw your own tables and do this yourself. In this compound statement, not only do I have PQR, but I also have not P, I have an and, I have an or, and I have a not R. So let's break this down. I'm definitely going to need a not P. So I put a not P in here. And I'm definitely going to need a not R. So I put a not R in here. And really the order of where you put that doesn't matter. As you play with it more, you might figure out ways that are more comfortable for you. So again, doesn't matter. You could have put the not R over here if you wanted to. You could have put the not P over here if you wanted to. Doesn't matter. It's just preference. So I have the not P, the not R. Now I need this statement. And lastly, I need the full statement. So we're just breaking down every single piece, just like PEMDAS. So I'm working inside, if you remember PEMDAS, parentheses, I'm working inside the parentheses. And inside the parentheses, I have a not P and an or. So you can see I put that there. Then I can work outside the parentheses. Outside the parentheses, I have a not R, and I have an or. I think I said or right here. I meant and. If I said or, I meant and. Sorry about that. So there's that last one. So we did parentheses and then outside the parentheses. And that's how I got all the columns. Now I can start working on each piece. Not P means I'm going to negate my P column. So that becomes 4, oh my, that is way too thick. 4 falses, 4 trues. Then I'm going to do not P and Q. So this might even help if you wanted to add a column. It might even help to have those side by side because when they're separated, it's kind of like, oh, what am I looking at? I'm going to use a highlighter for now because I can go in and erase my highlighter if I need to. There we go. I'm going to use colors here. So not P and Q. So I'm doing true and false, true and false, false and false, false and false, true and true. There we go. There's a true. True and true, false and true, false and true. So that's what you should have for that column. All right, so you should have 4 falses, 2 trues, 2 falses. Now we're going to look at not R. So I'm going to do a different color. Not R would be false, true, false, true, false, true, false, true. I was focusing on this column and I was negating each statement. Then for the last column, I'm doing this statement, not P and Q, which I've already completed, or not R. So these are all going to be joined by or, 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 all the way. That's going to make it easier for my brain, so I'm going to do that. So false or false, false or true, true, false or false is false, false or true is true, all the way down. True, false, true. So this last column is your final answer. That's it. That's what it's looking for. So it is a little bit tedious. You do have to, I would say the hardest part is setting up the table and getting organized. After that, it's kind of the same process over and over again. As long as you know that for and, they both have to be true. And for or, one of them can be true. Then you're golden. All right. Now we're going to explore equivalent statements, and we're going to use DeMorgan's laws to explore this. I had in a previous video a statement like this, and we translated it into words, and I said that we would learn a different way to translate that statement later. And so this is now, later is now. So I've set up a table here just to kind of help you explore this concept of equivalent statements. And you're not going to necessarily have to build a table like this on your own. It's just something that I did for teaching. So we have two statements, PQ, and it always follows. We have two trues, two falses, and then alternating. That's always the same. Then we're going to look at not P, not Q. So I'm going to negate I'm going to negate P and negate Q. Then I'm going to find not P or not Q. So I'm looking at the orange values with an or in between. So go ahead and try that column and come back. Now I'm going to look at, sorry for that, you should get false, true, true, true. Now I'm going to look at just P and Q. So my purple color, P and Q. So true and true, true and false is false, false and true is false, false and false is false. And for my last column, I'm going to negate my conjunction. I'm going to do pink. So negate, 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 false, true, true, true. So what I want you to focus on, I know that was a lot, but what I want you to focus on is the pink. Not P or not Q ends up being false, true, true, true. And not P and Q ends up being false, true, true, true. So we can conclude that these two statements are equivalent. So instead of saying it's not the case that P and Q, I could say, I can't remember what it was. Was it she has blue eyes and he is 6'3"? I could say she does not have blue eyes or he is not 6'3". Instead of it is not the case that she has blue eyes and he is 6'3". So those are equivalent statements. Since they have the same truth table values, that means that they are equivalent. So that was not P and Q translates to not P or not Q. So basically, if we were to distribute the negation, we're saying not P, to negate and would be or, and to negate Q would be not Q. Now I want y'all to do this table. Pause it, fill in the table, come back and check your work. So basically here you should end up with the two columns, not P and not Q, ends up being equivalent statements with not P or Q. So DeMorgan's law states that, because you should get 3 falses and a true, states that not P or Q is the same as not P and not Q, based on these columns. So, isn't that neat? All right, so now that we know DeMorgan's laws, we can answer these questions here. Use DeMorgan's laws to negate the following. So I want you to pause it, try these statements, and come back. Okay, so for the first one, I did a little background work or scratch work, if you will. To negate the statement, this is an or statement. So to negate P or Q, I have that up here. To negate P or Q, the equivalent statement is negate P and negate Q. So I changed it to you can not pay your bill now and you can not pay it later. Second one, same scenario. If we were to negate an or statement, negate or, that becomes not P and not Q. So she is not going. To negate that, you would say she is going. And to negate you are going, you would say you are not going. And that's it for that. Last one is an and statement. So if we were to negate an and statement, that becomes not P or not Q. So we say it is not summer or there is rain. All right, that's all I have for this lesson. Hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.